Alright, if you haven't seen the previous video on multiplying and dividing rational fractions where we actually just did multiplying, go back and look at that now. So previously we looked at multiplying, now we're going to look at dividing. So if you don't understand this, you will never ever ever understand this. And that's because they're basically the same thing. So if you haven't already, go back and find that video and watch that. And flying. And we'll go from there, okay? Good? Good. So we're going to do this again initially. Remember the fact that rational means fractions. We're going to do this initially with numbers to help you remember. Remember, if we have 3 halves, say divided by 7/8, at some point along the way you were taught that division is basically the same thing as multiplying by the reciprocal. Alright, so make sure that's fresh in your mind and you remember that. So to pull what we were doing into multiplication, we could rewrite this as 4 times 2, and when we do that, the 2's cancel out. We can only do this because everything's being multiplied together, giving us 12/7. So make sure you understand that division is the same thing as multiplying by the reciprocal. And because that's absolutely critical to understanding anything that we're doing from here on out. And so if you understand that and you understand the multiplying rational expressions thing, then pretty much everything out from here on out is kind of, I don't want to say easy peasy, but it could be a lot worse. So actually what you should like to do is definitely remember how to do factoring by grouping. So if you're not sure, go review factoring by grouping. Make sure you remember factoring by grouping. Make sure you remember factoring sums of perfect cubes. Make sure you remember how to factor differences of perfect cubes. Make sure you remember how to do differences of perfect squares and all that kind of stuff. So basically what I'm going to do here is I'm going to give you some problems to go work, and I mean obviously you could do what you want, but ideally what you should do is go work all these independently and then come back and watch the video and make sure that you're getting the same answer. So I'm actually going to go ahead and magically make all these appear for you, and then I'll work it out for you. Let's start by making sure this, the first one is called. We'll just number them 1 through whatever. Okay, so there are your magical problems that just appeared. Go ahead and see if you can get those worked out. Remember everything we talked about, how division is really just multiplying by the reciprocal. Go revisit the lecture on how to multiply rationals. If you have to, go revisit factoring by grouping, go revisit sums of perfect cubes, differences of perfect cubes or perfect squares, and all that kind of stuff, because you're going to need to know, you need to be like a factoring master to make this work, okay? So again, go work on those problems. I'm going to pretend that you did that, and so pause the video, go work on that. Assuming that that's happened now, I'm going to go ahead and work these problems out for you, okay? So I've got, the first thing I'm going to do is I'm going to rewrite this problem. Instead of a division problem, I'm going to make it a multiply by the reciprocal problem. Okay? You're going to have to remember your exponent laws here as well, and we'll talk about that here in a sec. So I've got x cubed divided by x cubed. Those cancel out. Now recall from your exponent laws, if I have x to the m times x to the n, that's the same as x to the m plus n. So if I have x squared times x to the 4th, that gives me x to the 7th. Or if I have even 1 over x cubed times x to the 10th, that would be x to the 13th. Okay, so these all need, the reason that your teacher made you memorize them is because you really, 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 really need to know them. All right. In this case, we're going to see that y squared times y to the 7th is going to come to 7 plus 2 is 9. On the bottom, I have 40 times 4, so that's 160. Okay. Now, it's going to be really, really tempting whenever you're starting these problems to look here, and if you're not looking at the division sign, you're going to want to cancel these out and cancel these out and all kinds of stuff. So don't do that. Remember, the very, very first step you always have to take is rewrite the division as a multiplication. Okay. Now again, the very, very first step that I'm going to take is I'm going to take my division and I'm going to rewrite it as multiplication. Okay. I'm also going to do any factoring that I can find. So I have x minus 1 over x plus 2. Now I can already see that 5 goes into 10 2 times. 5 divided by 10 would be 1/2. The 2's on the bottom. So I can rewrite that as 2. 2x plus 4. I can factor a 2 out of there. If I factor a 2 out of 2x, I have x. If I factor out a 2 out of plus 4, I have plus 2. The plus 2's cancel out with each other. And I've got x minus 1 over 2 times 2, which is 4. Okay. Let's try another one. Number 3. Again, the very, very first thing I'm going to do is I'm going to rewrite it as a multiplication problem. Even though I desperately want to factor it already, I'm not going to let myself do it because then I might forget to flip it like that. Okay? Now, this is going to be fun to factor. This is a 2x and an x. It's the only way to get 2x squared. Because this is a plus. Oops. This is a plus. So that means since this is a minus, they're both minuses. Because the only way to get a plus 5 is either a negative times a negative or a positive times a positive. 5 only gives me the options of 1 and 5, so I'm going to go with 1 and 5. I'm going to check. Outer, minus 10x. Inner, minus 1x gives me negative 11x, which is what I have here. Good. I'm going to erase all that jibber-jabber. It's just going to get really distracting. But if you want to see it again, just hit the rewind button. That's what it's there for. Rewind and pause are your friends. 5x minus 25. Hopefully you can see here. You can pull out a 5. If I pull a 5 out of the first term, I have an x left over. If I pull a 5 out of the second term, I have a negative 5 left over. And then over here, let's see, I've got a 10. I've got 4x minus 2. I can pull a 2 out of the first term. That gives me a 2x. The second term, I have that placeholder of 1. And joy of joys, these cancel out. 2x minus 1's cancel out. X minus 5's cancel out. And I don't want to get too crazy, so I'm just going to do a couple at a time. It leaves me with 10 on the top. And then 5 times 2, which is 10 on the bottom. 10 divided by 10 is just 1. Now see, isn't that pretty? So let's try this last one. And again, the very first thing I'm going to do is I'm going to rewrite the whole silly problem as a issue of, instead of a division problem, I'm going to make it as a product. Dividing by something is the same thing as multiplying by its reciprocal. Okay. Now this one might give you pause because this one you actually have to use factoring by grouping, and it's one of those things that people always want to forget. So I'm going to come in here and I'm going to group these terms, remembering that I can't group around a negative sign. So instead of leaving that as a negative, I'm going to say it's plus a negative, and now I can group around it. I can only group around that, around a positive sign. So if I factor the first one, I've got x times x plus 2 plus, I have the second set, I can factor out negative y, actually. If I factor a negative y out, I would get a plus x is left and a plus 2 is left. And if you're not sure, want negative y times x, negative y times 2, you get the exact same thing. And again, this is just something you get out of just doing it a whole lot. There's no better substitute for algebra than practice. I mean, algebraic experience. just doing it a bazillion times really helps. On the bottom, if you feel like doing all these steps at once, fine. If not, don't worry about it. But I'm just going to go ahead and do it. You've got a difference of squares. X minus y, x plus y. On the bottom, 2x plus 4. I factor a 2 out. And good to go. Again, it's one of those things, if you don't learn factoring, you're pretty much done until you learn it. You just have to keep going back until you really get good at your factoring. So here on the top, remember I have x times x plus 2 minus y times x plus 2. So I have x times something plus y times something. So x, and then coming in here like this. So it's x minus y, both times something. So x times something minus y times something is the same thing as x minus y times something. If you really want to write it in like this, you can, but it's the same thing as just saying that there. Alright, now here on the bottom, ooh, if I really want to get fancy, I'm not going to get fancy because I'm already confused. I'm just going to write it all out, and it's going to be perfect, and then I'm going to move on. Like that. Okay? So I've got x plus y's canceling out. I've got x plus 2's canceling out. And then I've actually got, oh, I'm out of colors. Let's do a different squiggle then. I've got x minus y canceling out. So the only thing I have left is a 2 on the bottom, and I have nothing left on the top. So I have to stick in a placeholder, giving me 1/2. And it's really kind of amazing if you think about this whole giant problem here. All simplifies down to exactly 1/2. It's actually kind of exciting and should give you bumps and chills. But this is kind of like a monster of a problem. So if you can get through this, you're good to go.